Hi, my name is Hira Ali, and I will be presenting the ignition system and magnetos, both in general and of the Piper PA 44180 Seminole. I'll go over what the ignition system is, the history of it, what magnetos are, and their relationship to the ignition system. I'll also go over what a dual ignition system is and how to perform an ignition check. The Piper Seminole has two engines that are manufactured by Lycoming. The left engine model number is IO360B1G6, and the right engine model number is LIO360B1G6. Each engine runs on 180 horsepower, and each engine has two magnetos, and each of those magnetos are connected through wiring all the way to a spark plug. And there are a total of 8 spark plugs on an engine, and 2 per cylinder, and there are 4 cylinders. What is an ignition system? The ignition system is a part of the engine, which is separate from the airplane's electrical system. The aircraft ignition system is responsible for creating and supplying the electrical spark that ignites the fuel-air mixture in the aircraft's engine cylinders. History of the ignition system. The Wright brothers used a magneto invented in 1902, built for them in 1903 by Dayton, Iowa inventor Vincent Grobby Apple. Some older automobiles had both a magneto system and a battery-actuated system running simultaneously to ensure proper ignition under all conditions with a limited performance each system provided at the time. This gave the benefits of easily starting from a battery system with reliable sparking at speed from the magneto. Components of the ignition system. Starting off with magnetos. Magnetos is one of the oldest components on general aviation aircraft. It's a technology that is more than 100 years old. Piston-powered aircrafts use magnetos because they keep working even if you have a shutdown and the entire electrical system stops working. The magneto-type ignition system is used on most reciprocating aircraft engines. Magnetos have engine-driven self-contained units supplying electrical current without using an external source of current. However, before they can produce current, the magnetos must be actuated at the engine's crankshaft, which is rotated by some other means. To make this happen, the aircraft battery furnishes electrical power to operate a starter, which through a series of gears rotates the engine's crankshaft. Then the turn actuates the armature of the magnetos to produce a spark for the ignition of the fuel in each cylinder. After the engine starts, the starter system is then disengaged and the battery no longer contributes to the actual operation of the engine. Next, we have spark plugs. Spark plugs are responsible for delivering electric current from the ignition system to the combustion chamber. The current is then used to ignite the fuel mixture within the aircraft's internal combustion engine. The ignition switch. The ignition switches provide on and off, left, right, both, or start electrical controls for both magnetos on the single engine aircraft. Source of electricity. The battery is the source of the electrical energy needed to operate the ignition system. The battery stores and produces electricity through a chemical action. Solenoids. Solenoids are a coil of wires used as an electromagnet. It also refers to any device that converts electrical energy to mechanical energy. The device creates a magnetic field from the electrical current and uses the magnetic field to create linear motion. A starter or a starter and a starter motor is a device used to rotate or crank an internal combustion engine to initiate the engine's operation under its own power. Starters can be electric, pneumatic, and or hydraulic. Wire links wires are connected to all of these systems, which make it up the ignition system. Next, we have what are dual ignition systems. Modern airplane engines, like the one in the Piper PA-44-180 Seminole, are required to have a dual ignition system. That is, two separate magnetos to supply the electric current to the two spark plugs contained in each cylinder. One magneto system supplies the current to one set of plugs. The second magneto system supplies the current to the other set of plugs. For that reason, the ignition switch has four positions: off, left, right, and both. With the switch on the L or R position, left to right, only one magneto is supplying current and only one set of spark plugs in each cylinder are firing. With the switch on the both position, both magnetos are supplying current and both spark plugs are on and working. The main advantages of the dual ignition system are it basically increases safety in case of one system fails. The engine may be operated on the other magneto until landing is safely made. It is extremely important for each magneto to be checked for a proper operation before takeoff during your pre-flight. This should be done in accordance with the manufacturer's recommendations. Unless the manufacturer specifies otherwise, it is advisable to turn the ignition switch from the both position to the farthest on position, then back to both, then to the nearest on position and back to the both. This sequence basically best assures that the magneto switch will be returned to the both position for normal operations. Also, the performance of each ignition system will be compared with the both performances. Another advantage is more complete. It's more complete and even combustion for the mixture, and consequently improves engine performance. The fuel mixture will be ignited from each side of the combustion chamber and burns toward the center. Finally, the ignition check. The ignition check has checks for like you check up on it and is performed during the aircraft's engine run up, which is right before each flight. The magneto check, as it is usually referred to, it is performed during the engine run up checklist. The ignition system is used to check the individual magnetos, harnesses, and spark plugs. To perform the ignition check, you must follow the RPM and stabilize and turn the ignition switch to the left position to see how many RPMs drop. Then switch it back to both, and then switch it to the right position and see how much RPMs drop. It is okay if it drops the same amount, around 75 to 180 reps per minute. These are the sources I got all of my information from, and some of it was from the Jeppesen online course too.